In this video, we are just going to do examples using the new properties we learned in the last two videos. So using the theorems about properties of limits and special limits using these two theorems. So using all that, I'd like you to give the following examples, so try the following examples, do as much as you can on each of these, and then I will go through them one by one. We've got find the following limits if they exist, if they do not exist, or they are unknown, say so. Problem 1 is all using this information. Suppose that limit as x approaches 3 of f of x is equal to 2, and limit as x approaches 3 of g of x is equal to 7, and limit as x approaches 4 of h of x is equal to 3. Find the limits below using that information. And then 2 through 6 are each just standalone problems. Find those limits if they exist, or say if they do not exist. So pause the video, try those, or try as much as you can, and then take a look at my solutions. Okay, let's try these out. So for the first one, the limit as x goes to 3 of 4 times g of x minus 4 times f of x minus 2 times g of x. So here we're just using the properties in the first theorem above. So properties include, constant multiples. A constant multiple inside a limit can just be brought out. We have the sum and difference rule, and so on. I think this was rule 3 and this was rule 4 in the properties above, in that first theorem above. And so using those for part A, the limit as x goes to 3 of 4 times f of x is 4 times whatever the limit as x approaches 3 of f of x is. That's 2 in this case, minus 2 times the limit as x approaches 3 of g of x, that's 7. And so we can just say, okay, that's 8 minus 14, that's negative 6. For part B, we also have rules above for exponents of functions that have limits defined as x approaches a value c. So again, we can just plug in what we know. The limit as x approaches 3 of f of x is 2 squared divided by g of x, that's 7. So this is 4/7, and we can just leave our answer like that. Part C is using part 9 of the theorem above of composition of functions. So composition of functions, we're taking the limit as x approaches 3 of h of 2 times f of x. So we see that as x approaches 3, 2 times f of x approaches 2 times f of x is approaching 2, so this is approaching 4. That means that we can plug in the limit as x approaches 4 of h of, well, this is just h of 4, so this is h of 4, which is 3. For the next one, the limit as x approaches 3 of g of h of x. So as x approaches 3, what happens to h of x? Well, this is a situation where we don't know what happens to h of x. So we have to think about the inside first and then the outside. And as x approaches 3, the limit as x approaches 3 of h of x is unknown. So from the information that we have, this limit is not determined by the info given. For our next problem, the limit as x goes to pi over 3 of cosine squared of x. First, just a notational issue. This is equal to the limit as x goes to pi over 3 of cosine of x squared. So having that squared right there, it's just something that's commonly done with trig functions. For example, tangent cubed x is just tangent of x cubed. So it's just a way to denote raising a trig function to a power. Okay, so by the theorem above, we know that this is just going to be equal to cosine of pi over 3 squared. So whatever cosine of pi over 3 is, and then square that value, that is going to be our solution. And we know that that's true because we know that cosine of x is continuous over its entire domain, and by the theorem above, the limit as x approaches any value for cosine of x is just going to be plugging in that value. Now, it might be a little bit of trig review to remember what cosine of pi over 3 is. If you don't remember offhand, you can use the unit circle. So remember that on the unit circle, it's not the best, but that's okay. The cosine of any angle, here the cosine of pi over 3, or about 60 degrees, so this is pi over 3 or 60 degrees, is the size of the adjacent divided by the size of the hypotenuse. So we often think of cosine x as the length of the adjacent leg of the triangle over the length of the hypotenuse. So what is that value? So the trick to think about for cosine of either 30 degrees or 60 degrees of pi over 3 or pi over 2 is to first think of a triangle that has sides all of length 1, and then cut that triangle in half. So we've cut that triangle in half, and now that half of a triangle has degrees 60, well, maybe I'll make that larger, has degrees 60 or pi over 3, 30 or pi over 6, and 90. So it's a 30, 60, 90 triangle. And this length is still 1 because it's from that triangle with all sides being equal. What's the length of this side? Well, it's 1/2. It's 1/2 because I divided this triangle down the middle. And so now I've already got, okay, here's my adjacent and here's my hypotenuse. That means that cosine of pi over 3 is 1/2. I'm giving a review video as well if you need any review for finding these trig values in general. It's posted under our review videos on an earlier module. So, okay, this is 1/2 squared, and 1/2 squared, when we square a fraction, we square the top, 1 squared over 2 squared, or just 1/4. Okay, limit as x approaches 0 of 3x squared minus 8x minus 1 over 2x plus 2. So if we have a rational function, all we have to do is check to see if denominator is equal to 0 as x approaches that value. In this case, it is not. So we've got 2 times 0 plus 2, which is equal to 2, which is not equal to 0. So that tells us that we can just plug in. We know that for any rational function, as long as the denominator is not 0, we can just plug our value in. So we've got 3 times 0 squared minus 8 times 0 minus 1 divided by 2 times 0 plus 2. And so that ends up just being negative 1/2. So negative 1/2 is our solution there. For our next example, we've got the limit as x approaches negative 1 of the cube root of x squared minus 5 over x plus 3. So here, again, we see that the denominator is not equal to 0 when x equals 1. Sorry, when x equals negative 1. And we're talking about a cube root. So it's okay if value inside is negative, because if we've got an odd root, that's fine. So, okay, all we need to do then is plug in. This limit will exist. All we have to do is plug in the value. So this is the cube root of -1 squared minus 5 divided by -1 plus 3. So that's the cube root of -1 squared, that's 1, minus 5, so -4 over a positive 2. This is the cube root of -2 when we simplify on the inside. And so we could find the cube root of -2. It's going to be some -1 point something something something, or we can just leave it as this exact value, and that is fine. Okay, limit as x goes to pi of the fourth root of 2 minus x squared. So the fourth root of 2 minus x squared. Now, one issue that could occur is if the interior is negative. So note that this is an even root, and the even root of negative is not a real number. So in our case, note that 2 minus pi squared is going to be less than 0. So without even calculating it, we know that pi is 3.14 dot 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 dot. So 2 minus pi squared is going to be less than 2 minus 9, 2 minus 3 squared, which again is less than, say, -7, which is less than 0. So this limit does not exist. And finally, we've got the limit as x goes to pi over 4 of 2 cotangent of x. So cotangent of x is cosine of x over sine of x. What is cosine of x? What is sine of x? If we want, we could do unit circle again. So if we've got the unit circle, this is now pi over 4, or an angle of pi over 4, or 45 degrees. And so this is if we pull out just the triangle, a 45 degree angle triangle. So it's 90 and 45, 45. Those two angles are equal to each other. So we've got a side length of 1 here, and then 2 equal side lengths. Let's call them both A, and those 2 side lengths are equal. So we know by the Pythagorean theorem that a squared plus a squared is equal to 1 squared. So 2a squared equals 1, and so a squared equals 1/2. And that tells us that a is equal to the square root of 1/2, or a lot of people prefer to write that as, it's 1 over square root of 2, and many people prefer to multiply by square root of 2 on the top and the bottom to give us square root of 2 over 2. Okay, so that tells us that cosine of pi over 4 is square root of 2 over 2, because cosine is the adjacent over the hypotenuse, and sine of pi over 4 is also square root of 2 over 2, because sine is the opposite over the hypotenuse. So both of them are square root of 2 over 2 divided by 1. Okay, so this is the, first of all, the denominator here is not equal to 0. So that is not equal to 0 when x equals pi over 4. So that means this limit does exist. And so this is 2 times cotangent of pi over 4, which is 2 times cosine of pi over 4 divided by sine of pi over 4. And so that gives us 2 times square root of 2 over 2 divided by square root of 2 over 2, or that is just equal to 1.